If your kid's division homework looks a little confusing, it's actually the same method you learned, just written differently. So first I'm going to walk through the standard algorithm quickly, and then I'm going to connect it to a method that students are using today called partial quotients. So if your student is using the box method for division, I'm going to make a separate video for that as well. But this video is going to tie together the standard algorithm of long division to partial quotients. So let's start with an example of 156 divided by 12. So if we're carrying out the standard algorithm, we would ask ourselves, how many times does 12 go into 15? Now that question implies it's kind of hiding the knowledge of base 10 value, and that's not really a 15 that we're considering. That's a 150. But it's a lot easier to think about 12 and 15, knowing that if 12 goes into 15 one time, that 12 goes into 150 10 times, right? We're just increasing by base 10. So that's one thing that the standard algorithm is hiding, is that it hides up a lot of this understanding, or it assumes that the person carrying out this procedure has that understanding. So let's move through the standard algorithm. How many times does 12 go into 15? Well, it goes one time. And remember that 1 is really a 10. So if we could think about division as sorting, as sharing things as evenly as possible, we can think about this problem as being, I have 156 things that I wanted to divide evenly into 12 groups. And my question is, how much does each group get? Well, I know for sure that if I have 156 items to split between 12 groups, I know for sure that each group can get 10. So if I give each group 10, then that's 120 of my items. So this subtraction here is saying, okay, I gave each of my 12 groups 10 things, which is 120 out of my 156 items to distribute, leaving me with 36 items left. So now we ask ourselves that same question. With my leftover 36, can I give each of the 12 groups a little bit more? So I know that 12 goes into 36 3 times, that I can find 3 groups of 12 in 36. So I'm going to write that 3 up here. And then I'm going to say, okay, if I gave each 12 group 3 more, then that's a total of 36 things being distributed, leaving me with nothing left. So a remainder of 0. So this 13 up here tells me that if I distribute 156 things evenly between 12 groups, each group gets 13 with nothing left over. It divides evenly. So now we're going to connect this idea to partial quotients. So again, if your child is using the box method, that's going to be a separate video. So we're going to do this same idea. We're going to say I need to divide 156 divided by 12. Now we're going to do this 2 times because I think it's important to see how this partial quotient method meets students where they are and can kind of give the teacher a better understanding of what they need to work on. So I'm going to think to myself, okay, this same question is being presented to me. I have 156 things to divide between 12 groups, and I want to know how much each of those 12 groups should get. So I know that 12 times 10 is 120. So if I take away 120 from 156, I have 36 left. I know that 12 times 3 is 36. If I take away 36 more, I have nothing left, remainder of 0. So now what my answer comes from is combining these 2 numbers together. I gave each 12 groups 10, then I gave each 12 group 3 more. So in total, each of my 12 groups got 13. And there again is our answer of 13. So let's back up again a bit and talk about how this partial quotients method is the same as what we just did, but then also how it might be beneficial for the students. So what we are doing here is partial quotients, just written in a little bit more of like a shorthand version of it. So in both cases, we're asking ourselves, how many times 12 goes into this amount, or how many I can give each of my 12 groups. And then in both of these scenarios, we are subtracting the amount of 156 that we've used by distributing. Right here, I said I have 10 groups, or